Hello and welcome to the Neurologic podcast, coming to you from the UT Dallas Center for Vital Longevity, which is dedicated to pursuing research that leads to cognitive health for life. Our goal is to educate you on the latest matters relating to cognition and the brain, and with each episode we will be interviewing leading scientists and sharing their insights and suggestions to promote cognitive health throughout the lifespan. My name is Amber Kidwai.
And my name is Sarah Munir.
And this is Neurologic.
Hey everyone, and welcome back to the show. Today we're excited to talk all about memory. But memory isn't just one thing. There are actually different types of memory, and today we're going to break them down and explore how they work and how they relate to each other.
Our guest today is Dr. Louis Renoult, a cognitive neuroscientist and a lecturer at the University of East Anglia in the UK. He studies how we remember things like life events, general knowledge, and personal facts about ourselves, and how those different kinds of memory are connected in the brain.
Memory is complex, and Dr. Renoult's work helps us understand how different memory systems overlap, interact, and even change as we age.
Before we jump into the interview, let's quickly define the three main types of memory, which are episodic, semantic, and autobiographical memory.
Episodic memory is your memory for specific events and details for things that you personally experienced. For example, if I ask you what you had for lunch today, you would mentally go back to that moment, remember where you were, what you ate, and maybe even who you were with.
Then we have semantic memory, which is your general knowledge about the world. So if I ask you what's the capital of France and you answer Paris, you're using semantic memory. You likely don't remember where or when you learnt that fact, you just know it.
And finally, there's autobiographical memory. You can think of this as sitting somewhere in between episodic and semantic memory. It includes facts about yourself, like how many siblings you have or when and where you got married. You're not recalling one specific episode, but you still know the answer because it's become part of your personal history.
These different memory types are all part of how we make sense of the world and our place in it. And with that, let's get into our conversation with Dr. Louis Renoult. We hope you enjoy this episode. Dr. Renoult, thank you so much for joining us today. So to start things off, could you tell us a little bit about your research background and what drew you to studying memory in the first place?
Yeah, thanks. So I did my undergrad in psychology, and then I moved to a neuroscience master and neuroscience PhD. So for like many students, I was mostly interested by clinical stuff, mental health, and then in my second year of psychology, I got some neuroanatomy, neurobiology classes, and I thought, wow, that's so interesting. So I remember going to talk to my teacher after the class and ask about that, and he mentioned the concept of psychophysiology, which I thought was really cool, like mixing psychology and physiology. So after that, I decided to go on more specialized neuroscience physiology, so that's why I moved around in my studies for that. But yeah, that's how it happened.
So I'd kind of like to start by talking about two types of memories that you do or you look at in your research, specifically episodic memory and semantic memory. So could you give us a quick overview of what episodic and semantic memory are and how they're different from each other?
Yeah, so people typically consider that episodic and semantic are part of what we call declarative memory. So these are memory we are consciously aware of, that we can consciously report or retrieve. And generally they define semantic memory as our general knowledge of the world, so a kind of memory of what we know about things and objects, whereas episodic is defined as our memory of specific personal experiences or unique events, as sometimes we say.
Okay. So like with semantic memory, like general world knowledge, for example, Paris is the capital of France, things like that. So that would be considered semantic memory, where we don't necessarily remember where we learned that information. Yeah, exactly. But it's just a general knowledge.
Yeah, exactly. That's a very important distinction. So people assume that like when you retrieve your knowledge about Paris is the capital of France, you're not retrieving the context of acquisition. So you're just expressing your knowledge in the present about Paris without thinking, oh, I learned that 2 years ago in my class.
Okay.
Yeah.
That makes sense. So when we talk about episodic memories, they're often described as being unique experiences and rich in context. Could you explain what we mean when we say these memories have spatial and temporal context?
Yeah, we sometimes say they are memories of unique events, and by unique we mean they have a specific context, as you said. So it's kind of an Einstein time of space concept. So like I remember where I parked my car today, and in time space that's today, and that's the location of the car park, and it's unique because it's different where I parked it yesterday potentially and the day after. But you could say the degree of uniqueness of the memory may vary, because if it's about parking your car, you could say, oh, but actually I tend to park it quite similar locations, and so they are unique to a point. Some memories are obviously similar. Yeah.
Mm-hmm.
So your research also mentions something called a component process model, where each of these different types of memory depend on the same basic neural processes, but each type of memory engages those processes to varying degrees. So could you tell us more about this?
Yeah, so the component process model. So initially it was proposed by Maurice Moscovich in the 1990s, and then updated with Roberto Cabeza later on. So it's a framework we use in our research. And the idea is instead of strictly separated memory system, you would have different type of memory that would rely on some of the same things. So there would be brain processes or components, if you want, they would rely on. So some example of that could be different type of memory might relate more or less on things like emotion, more or less emotion. Some memories might be more personally relevant, so high or low degree of personal relevance. Some memory might have a high degree of spatial or temporal specificity, so it's about a memory of what you usually do or what you did at a specific time. And a last example would be the capacity to evoke a scene. So some memory you would really see you back there, whereas other memory would be more vague. So I did this in the past or something like that. Yeah.
So your research has looked at how the same brain regions seem to be involved in both episodic and semantic memory. Yeah. One network that's often mentioned is the core recollection network, and then there's also a general semantic network. So what are these networks, and why are they important for semantic memory, which also can be broken down into personal and general semantic memory, and episodic as well? Yeah,
so to follow up, I would say that the reason semantic and episodic memory, that their brain correlates, would be similar is because they would involve some of the same components, right? So it could be that both semantic and episodic memory rely on the same kind of network, but that they differ in the degree of activation of this network. And maybe because episodic memories are more personal, for example, so they may realize certain brain regions that are sensitive to personal relevance would be more active. Similarly, they may be more temporally specific, so they may rely more on this brain region. But it could still be that the big picture is the same kind of network. So as you said, there is the recollection network, and it's the brain region that are typically active when we retrieve an episodic memory. And then there is the semantic network, and it's the brain region that are typically active when we retrieve a semantic memory. And what the research seems to show is that actually there is a large degree of overlap between them. It more or less corresponds to another network, which is the default mode network, and it's the brain region that are active when we are actually not doing a task. And so the reason why there is this overlap between this network about knowing about the world and remembering specific memory is not totally clear. And I think one of the most interesting mysteries of this overlap is subjective experience, right? So you think about, okay, Paris is the capital of France, or I remember going to Paris with my friend. In terms of subjective experience, that's quite different, but still seems there is quite a bit of overlap in the brain region involved. Yeah.
I mean, the fact that it overlaps with the default mode network makes me think, the default mode network is a network that's active when we're kind of not doing anything, right?
Not doing an active task.
Yeah. So when you're looking at it in the scanner, when somebody in the scanner, you tell them to just lie there and not do anything, but they're probably thinking about stuff, and that would involve recalling some memories.
Yeah.
If they're thinking, oh, I remember what I did this morning, or I need to remember to do something tomorrow, those regions would overlap because it is memory.
That's a great point. And I think that's the interpretation that several researchers take. So that you're lying in the scanner, not doing nothing, and you're still making sense of the world, right? Doing semantic processing, or you're still thinking exactly as you said, like about I'm going to go to the shop after. I remember doing that this morning. So there is this element. The other element, why it's similar maybe to the default mode network, is also it's kind of internal processing. So you're processing, your thinking is activating brain processes that are related to the self or to, it's internal processing versus external link to the external world.
So reinstatement is often something that's studied in the context of episodic memory. What exactly is reinstatement?
So reinstatement is a complex word to say to mean reactivation, and it's the idea that to remember a personal episode seems to activate some of the same brain region that you initially activate when you had the experience. So it's kind of this reactivation of the brain region that were active initially as you experience the event, and it seems to be the degree of reactivation seems to be a great predictor of how well you remember.
So you're reactivating the some of the regions that were active when you were encoding the information in the first place, and it kind of overlap.
So like, for example, like in our lab, we commonly look at like scene images or face images. So for faces, there's a specific like fusiform face area. And so we see that activated when a person's looking at a face, but also when they're remembering a face. And then the better the overlap between that brain activation, we say the better or more accurate their memories for that face.
Yeah,
Is
exactly.
that a good example?
Exactly. Yeah, excellent. Yeah.
So how do our personal experiences eventually become general knowledge? For example, how do multiple visits to a coffee shop help us better understand what a typical coffee shop experience is like when I'm not specifically remembering every single trip to a coffee shop, but I have this general knowledge of, when I go to a coffee shop, I order a coffee. Mm-hmm. So how do those individual experiences turn into this general knowledge?
Yeah, great question. So I think for many models in the literature, there is this idea of consolidation or semanticization. Like we have these experiences and these single episodes, and so if you go to your coffee shop after many times, then you might extract general knowledge or statistical regularities about this coffee shop in particular, or coffee shops in general. And in terms of brain processes, there is generally this idea that it's initially has greater reliance on brain region like the hippocampus, and then get consolidated in cortical regions. I think that's the big picture. One interesting aspect is doesn't mean that the individual episodes are forgotten. So it could be that every time you went to that coffee shop, or a few times you went to that coffee shop, you still have episodic memory for it, but you still extracted some statistical regularity. So you could have both semantic knowledge about the commonality of the experiences and access to some of the unique experience. So it doesn't mean it's the individual experience are necessarily forgotten.
Okay.
Yeah.
So it could still be there, but
that's
we're accessing a more general.
Yeah. So there are some memory models that propose that, like the transformation theory of Maurice Moscovich and others. They propose that indeed there is this over time or as we extract knowledge, it becomes more cortical. But I think what they also propose is that there are different ways to access information, and it could be that you have both conceptual knowledge and episodic knowledge for some of the same events of your life. Yeah.
And, like if I have a tendency for something to recall more of a general knowledge, but I get a certain cue that activates more specific knowledge of, or episodic memory, I guess, of that incident.
Yeah.
So a cue could kind of come in and reweight what I'm remembering or the specificity of it.
Exactly, great point. To me, memory is all about cues, right? Yeah. So you could say if you get a really good cue, there is not much you cannot remember. So true forgetting is hard to measure, and because it's exactly this. If I give you a really good cue, maybe you realize you had still a memory accessible somewhere. Yeah.
So we kind of touched on semantic memory and episodic memory. Your research also discusses something called personal semantics, which are memories that are about us but not tied to specific events. So maybe like our memory of routine events such as weekly family dinners or our daily commute. So could you explain personal semantics in more detail?
Yeah, so you can define personal semantics in quite general terms, like is knowledge about your personal past. But people have measured that quite differently, as you can guess, because it's quite general. For example, the psychologist Elizabeth Warrington has talked about things like skeletal CV. So you might have personal semantic knowledge about things that you might put on your CV. So I've got a diploma from this university, and I moved to Texas when I was 12 or something like that. So you might have personal knowledge like that. You might also have personal knowledge about your personality traits, the kind of person you are, like I'm a patient person, and about your opinions and beliefs.
So it could be like facts of ourselves.
Yeah, exactly.
Is a way to explain
Yeah. So it can be personal in different way. It can be self-reflective, so what I know about who I am, but it can be personal, just my life. I've got a sister, and I went to that place. So there are different ways to measure it. And another way that's more similar to episodic memory is we also have memories of personal repeated events. So you already mentioned every time I go to my coffee shop and stuff like that. So that's all part of personal semantics, right? It's about knowledge about personal facts and events from your life. Yeah.
Okay, nice.
So speaking of routine events, how does our brain consolidate all those similar experiences into a single representation? For example, we don't have a separate memory for every single commute to work we do. And, in a similar vein, doesn't every semantic memory begin as an episodic memory?
Yeah, I think that's what many people will think, that we first have. So, for example, you learn about Christopher Columbus, and it could be a lecturer talk about that, and over time you extract knowledge about Christopher Columbus. But as we mentioned, some hypotheses in the literature suggest that memories can still exist in multiple forms. So you're right, you're not going to remember all the times you went to the coffee shop, but it's still possible that you extract some generalities about some semantic knowledge while still having some access to some episode. Just to give an example, there is a study by a psychologist named Ulrich Neisser. There was a paper, an old paper in Cognition 1981, where they look at the Watergate and the memory of somebody called John Dean, and he was a counselor to Richard Nixon. And it was interesting because the conversation were taped, so they could check whether what he was saying was actually true. And what Ulrich Neisser found out is that memory of repeated events in that case, we are more or less accurate. So what he was saying about the repeated conversation were more or less true, but the memories of the individual episode were not that accurate. So it's in some cases we only can access the commonalities and generality across experience to a good with good accuracy, and sometimes some of the individual episodes are less accessible. So I think it's kind of a case-by-case thing, and as we discussed before, it also depends on cues that you might have.
So like with the coffee shop analogy, like if you go to the coffee shop every day, you might remember that like one day a couple of weeks ago the coffee was really bad. But you won't know. It will be harder to identify exactly which day that was unless you've got other cues to help with that, maybe.
Yeah, and I think it would be in a case like that. It would be a case of interference, right? So you could mix things up, and I think a bit like the example of parking your car is that you will extract knowledge, but if you, as you said, if you try to remember that one time, you might get it wrong or you might mix them up. So that's why there is this thing of memories of repeated events, which is kind of a mix of amalgamation of different episodes. Okay.
So you've also worked with patients who have semantic dementia. What have these studies taught us about how our different memory systems like episodic memory and semantic memory, how they work together? Yeah,
so we've analyzed, we've got a paper where we analyze autobiographical memories of patients with semantic dementia. And I think in these studies of autobiographical memory in semantic dementia, the general finding is not surprisingly a decrease in general semantics. So these patients are known to have a selective impairment in general semantics. But what we found in our study is that there was also an increase in personal semantics. And you could say it's kind of compensation, but I think there are some very nice studies by Julie Snowden in the UK in the 1990s and 2000s, where she showed that actually in patients, sometimes they lose general knowledge about the world and objects, but they still have preserved personal knowledge about the same object. So, for example, you might forget what a teapot is, but you know what that's my teapot, and I know how to make tea with it, and etc. So there is this kind of personalization of semantic knowledge in SD in semantic dementia.
So would that mean that you would only recognize your own teapot and not other teapots?
Yeah, I mean, sometimes it's biased because if the patient is tested at home, it could be based on other factors. But I think that's the general idea. I think in experiments about this that I mentioned, they tend to find that patients have better recognition of location or people or objects that are personally significant. They have some kind of personal relevance compared to exemplars of the same objects or that are not personal in a way. Yeah.
So can having general knowledge about something help us remember specific events? So in other words, can semantic knowledge prime the retrieval of episodic memories?
Yeah, great question. So I think there are a few aspects to that. One is what we call self-reference, is the finding that if you're asked to study something in a psychology experiment, so if we ask you to study some words or pictures or faces, you're likely to perform better if you can relate to the self, right? So if you think about something personal, so for example, if it's a word and it's a personality trait, patient, and you think, am I a patient person? Then you're going to remember that word better than if you don't think about that or think about what it means. So there is the self-reference effect, but there is also the fact that personal semantics can prime episodic retrieval. So in models of autobiographical memory, it's often the case that people propose that one typical way to remember specific episodes is through retrieving general knowledge. So you might, think about your knowledge about coffee shops, and then suddenly think about that one episode, for example. That could be a typical way to remember something specific. Yeah.
You've also studied something called autobiographically significant concepts. What makes certain ideas or memories, I guess this is kind of what you just touched on, but what makes certain ideas or memories more personally meaningful than others, and how does this affect how we remember them?
Yeah, so I think it's an example of difficult way. It's difficult to separate strictly semantic and episodic memory because, as you said, there are some semantic knowledge that's kind of personally significant, and it means in that case, in these studies, that you see that some people associate semantic knowledge with episodic memory. So what they use in these studies is often knowledge about famous people, or for example, you might think about knowledge about a certain president of the USA, and then, okay, I've got knowledge, I know what they did, and etc. But then you might, that might activate a specific episodic memory. For example, I remember arguing with my friend about whether they should be related or not, something like that. And what we found in this experiment is semantic knowledge that's kind of bound or attached to episodic memory is associated with better performance. So if you present, for example, this name in an experiment or the face of that person in an experiment, you realize people have faster reaction time or they perform better in recognition memory test, even though they are not thinking about the episodic memory at that time, because we tend to ask about the episodic memory only at the end of the experiment, if that makes sense.
So it kind of pries them to be faster.
Yeah, it's kind of, this association with episodic memory seems to have be associated with a performance boost somehow. Yeah.
Okay.
So why is it that we're better at remembering meaningful experiences compared to things like random patterns or nonsense words?
Yeah, my personal interpretation is that we are meaning-making machines, as we are not very good at processing anything that's not meaningful. So I think some interpret that not just for memory, but in general, the way we do cognition or perform cognitive tasks, it's a lot about meaning making. In experiment where people have tried to present things that were not meaningful, like abstract geometrical shapes and stuff like that, and ask people to remember them, what we found is either they are not very good, and when they do remember them, often we find that they are making sense of it. So they even though that looks like an abstract geometrical shape, you would find, some participants said, it looked like a man, or it looked like a fish, or whatever. So they find a way to make it meaningful, and then they remember better. And as you know, that there is also this general principle that when people do what we call deep processing, when they are able to extract meaning about things, they tend to remember things better. So it seems to be something really fundamental about how we process stimuli. And
so it kind of seems like inherent to like what our brain does. It just loves patterns. So it kind of reminds me, like when you were saying the abstract, how like, you know, when we look at shapes in the clouds, and then our brain like immediately is trying to like find patterns in the clouds, and we're really good at that. So it makes sense that we're better at remembering things that we put meaning to.
Yeah, exactly. And there is this test, for example, the Rorschach test, where you present ink blots, and then people still project something about that. And to me, this question is maybe related to what we said about the similarity between episodic and semantic memory, right? So it is because the way we remember with episodic memory, the ultimate goal is to also make sense of the world, as we remember meaningful things. So I think that's part of the reasons.
So does the ability to form new memories decline as we age? So do we end up relying more on our existing general knowledge?
Yeah, I think it's fair. Older adults can still obviously form new episodic memories, but as you said, there is this trend that we see, a strong trend in the literature, that when you ask older participants about their personal past, they tend to provide more conceptual semantic knowledge than the young adults, and a bit less specific perceptual details. So we just don't know exactly why. So there are different interpretations in the literature. One is social, like they want to tell you a good story, they have this narrative ability, and interestingly, if you ask people to rate this memory, so they rate the memories of young or older adults in how interesting they are. There are these studies showing that actually people rate higher the older adults' memory, that they think they are more interesting. And so that's one hypothesis. The other hypothesis is, as you implied, there might be an episodic deficit, and so older adults produce more semantic details. But in our own research, we don't necessarily find that. We find that older adults produce more semantic knowledge, even if it doesn't depend on the instruction. So whether you ask about semantics or whether you ask about episodic, they just produce more semantic knowledge. So to me, to us, it's not just compensation.
Yeah. I mean, semantic memory actually doesn't decline as you age, right? It's only episodic memory that does. And so it kind of makes sense.
Like semantic memory eventually declines, but much slower pace than episodic.
Yeah, not as early and not as steeply.
Yeah.
But then also older adults will have had more life experience and created more semantic memories in the first place. So it might just be that they have so much more semantic memories to draw on.
Yeah.
And maybe it's kind of a more efficient use of their resources to draw on that.
Yeah, that's a great point. Yeah. And I think that's an hypothesis that people have proposed in the literature, that the lifetime experience type of hypothesis. It's a very fair point. And they just know more. And I think another bias that we are discussing with colleagues is that the typical scenario in a psychology experiment of aging research is that it's a young adult, a research assistant, for example, that interview an older adult. So it could be that one of the reasons is that the older adults contextualize and provide information about how the world was or is to this young person. So it's an important confound that I think several colleagues are trying to address.
So basically, like in your past research, what you're saying is that older adults just provide a more elaborate description than young adults when you're asking them to recall like remote memories.
Yeah.
So they go more into like details about what happened to them in the past than like the recent past.
Oh, yeah. We don't always find a time period effect. So the fact that they produce more conceptual semantic knowledge, we found that across time periods. So it doesn't, in our research, it doesn't really depend if it's last year or 10 years ago. They tend to always do it. But and also less specific episodic, like perceptual details. Yeah.
Okay, so like less episodic, as in they might not talk about the context of something, or like this is exactly where I was, this is what I remember, like the very details, but they're good at the general.
Yeah, exactly. Knowledge. So for example, if it's a birthday party, a young adult might tell you, I was sitting to the left of my friend, and then we had this cake, and it was looking like this, and then my other friend said this. So some very specific perceptual or spatial or maybe temporal details. Well, and older adults might put greater focus about other similar birthday parties and their experience related to celebrating birthday party, and some more general type of gist type of knowledge.
Okay. Yeah, that makes sense. So how does our brain use our past experiences to help us navigate and understand new situations? So, we're constantly updating our like knowledge of the world, for example, and that as we're integrating or like encoding these new memories, we're also relying on these past experiences. So what's happening there?
Yeah, so I think a lot of people are interested in what we call predictive processing, and I think they're talking about the role of what we call priors. So our brain is trying to predict what's coming next or what will happen, and we are using this kind of semantic knowledge to do that. So I think that's a big field of study. In our research, we look at semantic knowledge a bit differently. What you realize when you study semantic memory is it's also related to novelty processing. So according to some people, when you have semantic knowledge about something, it also allows you to predict the future. And for example, if I recognize an object as a tomato, then I don't have to reprocess and make deduction and inferences. I can just say, I can eat that, and etc. Put it in my salad. If I recognize a picture of a restaurant, or I know what's going to happen, and a waiter is going to come, and etc. I'm going to have the bill, etc. So it's also having the semantic knowledge also allow us to predict new situation and to kind of predict the future. What we've seen also in our research is that this kind of novelty detection aspect of semantic memory is that if you repeat your stimuli in an experiment, so if you repeat the word restaurant or tomato, then what you see is that the semantic system tend to saturate. So like if it's more sensitive to novelty, so like it seems your participant no longer process necessarily the meaning of the words, or the brain activity related to semantic processing is kind of reduced. So there is really this kind of novelty processing aspect of semantic processing. Yeah.
Yeah, that's interesting. We had a recent episode where we were discussing semantic dementia patients and how individuals who kind of lose knowledge of the world, they have a very difficult time imagining the future because they no longer can, they no longer in the present understand, everyday knowledge. So how do you predict what's going to happen, or how do you plan for the future?
Yeah.
So we did have an interesting discussion on that.
Yeah, and I think some people use the concept of scaffolding, like you use your semantic knowledge to build episodic memories and think about the future because it gives you a good scaffolding of what might happen, and as you say, schema knowledge and things like that. Yeah,
and our brain is constantly using past information to help us predict new information and integrate that into our knowledge base.
And sometimes it's helpful and sometimes it's misleading because you might overgeneralize or misremember something because you're using your schema knowledge about what usually happens. So that can also mislead you sometimes.
So when new information conflicts with an existing memory, how does the brain reconcile that discrepancy?
Some people call this prediction errors, so the difference between what you predicted and what actually happens. And I think some research propose that you have reduced accessibility for outdated information. So when something is no longer, so some kind of memory is no longer relevant for what's happening right now, so it may be less inhibited or less activated. But I think, again, we're coming back to forgetting. It doesn't mean you're already forgotten, right? So if you think there is construction work and you have to drive different routes to go back home or to go to work, then you might not activate or inhibit the previous route, but it doesn't mean it's forgotten, right? So later on, you might need that representation again. Yeah.
Okay. So your work has also shown that memory is essential for building a sense of self. So could you explain the relationship between memory and self?
Yeah, well, it's a quite complex question. So I think people tend to view sense of self as something that has multiple aspects or components. So we tend to talk about the self as that one thing, as if it was like an one process. But I think most people agree that our sense of self is composed of multiple aspects or components. So in the literature, I think people would agree that your sense of self includes maybe episodic memories of your life, your individual experiences, maybe, as we discussed, semantic knowledge about who you are, the kind of person you are, your personality, what you like, what you dislike. Sense of self might also include things like even bodily sensation and how does it feel to be you, like in the moment, and these things like proprioception. So it's quite complex construction that we think is kind of integrated to give us a kind of unified sense of self. Yeah.
Yeah, but so all of our past experiences and the memories that we have, as we go through life, that kind of helps us build this sense of identity.
Oh, yeah.
And I'm wondering, with older adults, when they have more difficulty with forming new memories, like episodic memory, do they have more trouble updating their self? Because I know with young adults, we're constantly, learning about ourselves and growing. And I wonder if that's one reason older adults tend to kind of be, I guess this is not the good term to use, but stuck in the past, as in they don't really change their personality much as they grow older. And I wonder if that has something to do with this inability to form new memories, to update already their sense of self.
Yeah, I think it's totally fair, and you can think about the mirror image of that. That many researchers think we don't really have episodic memory before we have a sense of self. So we might need, depending on how you measure it, you might need to be 3 or 4 years old before you get actually true episodic recollections. I think what you're saying it makes sense. You might have the mirror image in aging, where you're kind of less having less update about your sense of self later on. Yeah.
So many people report having very detailed memories of where they were doing major historical events. So something that has a lot of emotion involved in it. So something like, for example, 9/11, people remember exactly where they were at that time. And, these are sometimes called flashbulb memories. So are these as accurate as we think they are?
I don't think so. So my group didn't really do a flashbulb memory experiment per se. We did the autobiographical significance kind of concept, which is kind of related. But I think you're right. I think the literature shows that even though it's very vivid, very emotional, and we feel like we are back there, we remember where we were, when people have tested participant multiple times, we realize that actually it's not more accurate than other memory, and sometimes it can even be worse. So it's a case by case thing. But yeah, I think it's a fair point. It's not more accurate, even if it feels very vivid. Yeah.
That's really interesting. There's a separation between vividness and accuracy, because you kind of just assume they go together.
Yeah,
If you see it clearly, it must be accurate.
And it must have happened.
Yeah.
But that's
not. That kind of gives you
the
confidence in the memory in the first place. It's like, oh no, I see it clearly, so I know that's what happened.
Right.
So that's kind of
the flashbulb memory. I think is kind of. It's not necessarily. It's always inaccurate, and the fact that people have been tested multiple times is a factor, right? Because any memory where you're tested multiple times, I think what the research shows when you're remembering is that there are some details that you forget at time 2, and sometimes you add other details at time 2 that were not at time 1. So that's a natural way to remember. It's just that when it's public events like flashbulb memories, we know what the truth is, and so we reveal all this inconsistency in that case. Yeah.
Yeah, that's interesting. That every time you do remember something, you are kind of opening up to manipulation, right? And so you kind of restore that memory in a slightly different way to where it was originally. So every time you're recalling it, you're altering it a bit. And so something like 9/11, where you probably told that story so many times to people, it's probably changed a lot over the years.
It's changed so much since the original memory formed, actually.
Yeah, no, it's a great point. So when you remember, you re-encode. I think many psychologists have noticed this from Endel-Tulving and obviously in neuroscience studies. So there is this thing like reconsolidation. So I think, it's a very important point. What is thought to happen is, if you ask me to remember something now, it could be that I re-encode it with some of the context that's going on right now. Maybe I am in a good mood, and maybe I'm gonna misplace in the memory some of the people that are here now and things like that.
That's a good point. So, I mean, talking about misplacing things in our memory, in today's digital world, we all rely so much on our devices to support our memory, right? We're constantly offloading information to them. We use our calendars and reminders and so on, alarms and everything, so we don't have to remember what we need to do, in the next few days or whatever it may be. So how do you think that's affecting our memory?
Yeah, great question. I think it's a very timely question that many people are wondering about. The studies I'm familiar with, there is the spatial study where people have a GPS, and you realize that they are relying on GPS to find their way, and then there is this idea that using GPS makes your spatial memory worse potentially. So it could be a good idea to not always rely on GPS. There are obviously these famous studies with taxi driver in London that shows that training your spatial memory helps with plasticity and memory performance. I'm familiar also with studies where participants could Google, so you have something to learn, and you might be able to Google it later or not. And I think it boosts confidence in people's knowledge, but it kind of over boosts it, like they might be overconfident about what they know and what they can remember. For AI, I'm not that familiar with many studies, but I think many of us will want to measure that because it's so prevalent right now. And if you ask AI to write your essay, that you're not very likely to remember the content later on.
Yeah, because you never wrote it.
Yeah, exactly. You never wrote it. Yeah, I'm curious to see. I mean, like offloading memory to all these devices is obviously still very new. So, what I'm curious to see is how does, semantic memory or these general knowledges form when I know that I can just Google something. Like I don't need to necessarily store something if I know I can just look it up. So I'm not as consciously encoding it. So, it'll be interesting to see like how young adults today, how their general knowledge of the world changes as the generation goes on, and how that affects their memory as they grow older, when people tend to start relying more on these general knowledges.
Mm-hmm. Yeah, and I think you can take a positive spin to it, because there might be this thing that you're overconfident on your knowledge, but actually you don't remember. But also you could flip it around. You could think, I'm gonna use some of my brain resources to remember and encode things, and I'm gonna also use Google to as a cherry on the cake, right? To embellish it. So it's not necessarily always negative. So there might be some. Yeah,
you could be more selective at what you want to remember.
Yeah, potentially, yeah.
But also now with the devices and with social media, like for example, if I attend an event and I take pictures of that event, it's likely everyone else in the room took pictures of the event too. And I'm going to see them all posted online. And so I'm instantly going to recall that memory and then embellish it with all those other perspectives of the things that the other people noticed that I maybe didn't, and I'm wondering how that affects.
Yeah, to have all these cues. We are talking about the importance of cues. So you could, another positive way to see that is that you've got a lot of possible cues to retrieve and reaccess some of these memories.
So before we wrap up, where can our listeners learn more about your research?
Well, they can look at my website at UEA, University of East Anglia, or they can follow me on Blue Sky, and I think that's it.
Okay. Well, thank you so much, Dr. Renoult, for taking the time for sitting with us today and sharing your expertise with us. And we look forward to keeping up with your future research.
Thanks for having me.
Thank you for listening to Neurologic, a CVL podcast. If you like what you're hearing, please follow and share with others. This podcast wouldn't be possible without the support of our team and the incredible work that goes on behind the scenes. We'd like to give special thanks to Patricia Moran for editing this episode. To learn more about the Centre for Vital Longevity, just look up cvl.utdallas.edu, and here you'll find information about our research as well as information on how to volunteer to participate in our studies and how to donate to support innovative research to understand, protect, and enhance the vitality of the mind across the lifespan. Join us next time as we continue to explore the latest research and strategies for keeping our brains healthy throughout our lives.